we are going to discuss about probability 7.1 experimental probability. So let's straight away go to the exercise. So in 7.1 question 1a, the tally chart shows the colors of flowers that grew from a mixed packet of seeds. Copy and complete the table. So on the right hand side you can see there is a table with a color. In tally marks it will show the number of flowers there, and there is a frequency column as well, right? For red, count the tally marks and see how many are there.
12.
Yes?
It's 12.
It's 12. So write down 12 in the frequency row. And then blue, it says 7. So how do you write it using the tally marks? You draw 4 lines and the fifth one you are cutting them, right? And then another 2. Altogether you need to draw 7. Right. Then for white, how many whites are there? 6. Is it clear how to do it?
Yes.
Right. What is the total frequency? Total frequency means all 3 frequencies added together. So that means 12 plus 7 plus 6. What is the answer?
25.
It's 25. Total frequency is 25. What fraction of the flowers are red?
12 upon 25.
Now, how many red flowers are there? 12. Out of, what's the total number of flowers? 25. Right, for the next question, question 2. How would you describe each of these probabilities? Choose from impossible, unlikely, even chance, likely, certain. So for A, 0.4, what can you say? Which one is the most? Yeah, it's more like even chance because it's closer to 0.5. So you can say even chance. Can you note it down? Right. 19 upon 20.
It's like almost certain.
It's certain. You can say it's certain. 0.5.
Even chance.
Again you can say even chance. 1 upon 50.
Impossible.
No.
Unlikely.
Unlikely. It's unlikely. 60%
Likely.
likely. And 0 is impossible. That's how we describe each of these possibilities. Is that clear?
Yes.
Right. Okay. Next part. There's a key point here. To find the experimental probability. How do we do it? So you can estimate the probability of an event using the results of an experiment. This is what we call as experimental probability. So this equals to the frequency of event divided by total frequency. So we can write down the equation experimental probability equals frequency of event divided by total frequency. So keep this in mind. Now we are going to learn this in the worked example. Okay?
Yes.
Right. See, in the worked example it says Andrew dropped a drawing pin lots of times. It could fall point up or down. He recorded the results in a frequency table. Work out the total frequency. Work out the experimental probability that the pin will fall point up. And work out the experimental probability that the pin will fall point down. Right. Now you can write down this information in the table as follows. Position, point up, point down. Then the frequency for each position is given there. Below that you can calculate the total frequency. So to get the total frequency, you have to add the frequency of the pin falling with point up and pin falling with point down. So it's 83 plus 17, which gives you the total frequency 100 there. Is that clear?
Yes.
Experimental probability means how many times did the pin fall with point up? 83. How many times in total did we experiment it? 100. So you are writing it 83 upon 100. So you see, the total number of times Andrew dropped the drawing pin is 83 plus 17. That's how we got 100 for the total frequency here, right? Then the experimental probability equals to the number of times the pin fell down with the point up divided by the total number of the total number of drops. That gives us the answer 83 upon 100. So we can write it as 83 upon 100, 83% or 0.83. So you can write it as a fraction, you can write it as a percentage, or you can write it as a decimal number there. Is it clear?
Yes.
Right. Then for the point down, what is the frequency? How many times did it fall with the point down? 17 times. What is the total number of drops? It's 100. So you can write 17 upon 100 as the experimental probability of the pin falling with the point down. Is it clear?
Yes.
Now if you notice something, if you add the two experimental probabilities with point up and down, you can notice that it adds up to 1. Here on this lower blue box you can see it says, notice that the probabilities add up to 1 because 83 upon 100 plus 17 upon 100 equals to 100 upon 100, which is equal to 1. Is that clear?
Yes.
Right. Keeping that in mind, can you do this question? Question 3. It is similar to the previous one. You just have to understand the concept of this, and with that basic knowledge, can you just fill it up and tell me the answers? Okay, I will give 5 minutes. You can pause the video for 5 minutes and then do the question, write down the answers and check the answers once I start explaining. Okay, so this question says about a hospital trying out a new kind of knee surgery on some patients. After 2 years, patients were asked how they felt. The results are shown in the frequency table. So they have given you the data here and they ask you to copy the table and work out the total frequency. So what's the total frequency here? 80. So you add up all three and you can get the total frequency here. Right. Calculate the experimental probabilities. Yes?
60 upon 100.
60 upon
80.
80. You have to write it. You have to write the frequency for each item upon the total frequency. So you can further simplify it and write it as, you can divide it by 2,
3 upon 4.
3 upon 4. And if you write it as a percentage, you can see it's 75%. What about people with some improvement? What was the experimental probability there? It's 15 upon 80. Right. Can you divide it further? Yes. If you divide it by 5, 3 upon, yes, who can tell me the answer?
14.
14 is 70, no?
We divide by 5, no?
It's 3 upon 16, right. What about no improvement? It's 5 upon 80. Once again it's 1 upon 16, right? Right. Now they are telling in part C, the hospital claims that patients undergoing the new surgery are very likely to improve. So they say very likely to improve. The word very likely means it's closer to 100%. Right? Comment on this claim. So how do they say it? You can see by looking at the experimental probability there, we came across that 75% of the patients who have undergone through this type of treatment has shown that they have been symptom free, right? So 75% of the patients who have taken this treatment have shown that they have ended up being symptom free. So this helps us to claim that patients who are undergoing through this new surgery are very, very likely to improve. Is it clear?
Yes.
Right. So you can write down the answer using the experimental probability values that you got. Okay?
Yes.
So for question that part C, you can write down the answer like this. The data supports the hospital claims as 70%, 75% of the patients were symptom free after treatment. The data supports the hospital's claim as 75% of the patients were symptom free after treatment. Okay, so starting from question 4, a skateboard manufacturer gave 100 customers a set of newly designed wheels to try out. The table shows how long the wheels performed well for. So you using the given information about the time in months and frequency, you have to do the experimental probability. You have to calculate that. Did you do it? Okay. Can you tell me the answer? Can you tell me the total frequency?
7 upon 10. No, it's 100.
Total is 100. 100, right. So experimental probability, we are going to write the frequency for each one upon the total frequency, which is 100, right?
Yes.
So for time 5 months, what's the experimental probability?
5 upon 10.
It's
7 upon 10.
7 upon
100.
100.
100.
Did you write 10 there?
No, I wrote 100.
So it's 7 upon 100. Then for the second one, for 6 months, it's 14 upon 100. Then the third one, 7 months, it's 35 upon 100. Then 8 months, it's 25 upon 100. Then for 9 months, it's going to be 15 upon 100. Then 10 months, 3 upon 100. and for 11 months it's 1 upon 100. Right. So what they are asking you is to find the answers as percentages. So how do you write them as percentages? First one, it's going to be 7%.
7%.
Yeah. Can you write it down if you are not written already?
Yeah.
So it's 7% for the first one. Second one, it's 14%.
14%.
Third one, it's 35%.
25%.
Next one is 25%. Then 15%. 3% and 1%. Is it clear?
Yeah. Yes.
Estimate the percentage probability that the wheels will perform well for longer than 8 months. For longer than 8 months means, are you including 8 months? No. Longer than 8 months, no. So you have to choose 9, 10, 11 months. Right? So what are the percentages we got for 9, 10 and 11 months? It's 15, 3 and 1% respectively. So you can add them all and get 19%.
We should add them also. Or
Yeah.
just put 19.
You can write it like adding them together also. Final answer is 19%. Okay, part C, reasoning. Why do you think the wheels performed well for different amounts of time? So why do you think they performed well for different times? These are skateboards. So maybe these frequencies change due to the types of surfaces where they use them, right? So you can give a reasoning like that. Okay. So the next question. Okay. So for those who needs a reason, the reasoning, you can write down the answer. The skateboards were used on different types of surface. Right, so question 5 says, a manufacturer tested a new kind of mobile phone battery. They claimed that there is a 95% experimental probability that the battery will last 30 hours with average use. Can you tell from the probability how many batteries were tested? By looking at this, by looking at the experimental probability they have given you, can you tell how many batteries were tested in total?
100.
30 is the number of hours they are saying it will last. If you use it like with average use, they say that it will last for 30 hours. I am asking, what can you say by looking at the probability given there, that how many batteries were tested for this purpose?